Howdy folks, welcome to lesson 2 of the CompTIA Network Plus course, or should I say the N10-009 course. Today's lesson is called Compare and Contrast OSI Model Layers, or should I say OSI Model Layers. Some people just call it OSI. I just normally call it the OSI model. Now, if you don't know what the OSI model is, folks, it's basically a set of rules that networking has to follow when communication takes place from one device to another. So if we've got two computers and one wants to communicate with another one on the network, there's a set of rules that these machines have to abide by for communication to take place and for it to move from one machine to another. Now, with regards to this set of rules, that would be the OSI model, or should I say OSI model. It consists of 7 layers. Now, if you're wondering what these 7 layers are, it starts with application, so that's going to be one of them. Then we've got the presentation layer, followed by the session layer, transport layer, network layer, data link layer, and lastly, folks, the physical layer. Now, the order I've got them in here for you guys is actually backwards, believe it or not. So out of these 7 layers I've just mentioned to you folks, the bottom one being the physical layer is actually layer 1. The data link layer, that would be layer 2. The network layer would be number 3. Transport's number 4. Session is 5. Presentation is 6. And application is, of course, 7. Now, if any of you guys happen to be studying for the Network Plus exam, this is unfortunately something you need to know for your exam. You need to know what the 7 layers are, so you guys can see them on the screen right now. You also need to know in what order these layers need to go in. So, for example, you need to know physical is layer 1, you need to know the transport is layer 4, so you need to know what the order is in which these layers have to go into. And to help you remember the order of these layers, there's actually a little bit of a motto, if you want to call it that. So one of the mottos you get, and there's actually lots of ones online, and unfortunately I cannot take credit for this one, is please do not throw salami pizza away. That, guys, is just one of them. So if you go look it up on Google, you'll find there's actually quite a few of them. Some of them are very creative. I cannot take credit for this. I do not know who came up with this, but it's been around for a very long time, and you'll find this mentioned in many, many courses. Now, with regards to that little phrase there, if you look at the first letter of each word. So if you look at please, that would be the letter P. If you look at the word do, that would be the letter D. So if you look at each of these letters, you'll notice they correspond with the layer. So please, the P is for the physical layer. Do, the D, is for the data link layer. And then the word not, the N in it, would be the network layer. And I think you guys get the idea from that point forward. So if you find yourself not being able to remember what the 7 layers are, by all means, guys, remember this little phrase. Please do not throw salami pizza away. There's quite a few other ones as well. So I encourage you to go look online. Maybe you'll find one that's actually easier for you to remember. But this one I personally find is not too shabby. So remember that little phrase, and that, guys, will help you remember the 7 layers. And it will not just help you remember the 7 layers. It'll especially help you remember the order. I personally have seen a lot of people remember what the 7 layers are, but for the heaven's sake, they cannot remember in what order these layers need to go. So this little phrase will at least help you get that out of the way. Alright folks, now that we know what the 7 layers are and in what order they need to go, I think I'm going to start you guys off with the first one being the physical layer. Let's start explaining this one first. Now folks, the physical layer of the OSI model, which we call layer 1, is responsible for the transmission and the receipt of signals that represent bits of data from one node to another. Now, if you don't know what a node is, most folks just call that a computer. So for the most part, it's going to be something like a laptop or a desktop. And if you don't know what bits is, that's normally ones and zeros. So computers and machines, they normally communicate using ones and zeros. That's what we mean by bits. Now, this communication, guys, takes place via cables in most cases, but it can also be wireless. You guys have got to remember, when the OSI model was established many, many, many moons ago, for the most part back then, people were communicating via cables. These would be cables like your normal LAN cables, in other words, Cat5, Cat6. They were communicating via coaxial cable, hope I'm not butchering the name, and they were communicating via fiber optic cable. So for the most part, it was cabled communication, but it's not limited to cable communication. Layer 1, guys, can also be wireless communication. Now, don't get me wrong, when I say wireless, I don't mean the actual access point. No, I mean the wireless transmission. Not to be confused with the actual access point itself. Access points, guys, fall under layer 2, but the wireless communication between said access points and your laptop and stuff, that, guys, falls under layer 1. So yes, layer 1 is predominantly things you can actually touch. I think the word physical is where a lot of the confusion comes into play. People think it's predominantly things you can just touch, which is not entirely true. It can be wireless. It can be the wireless transmission between devices as well. But if we talk about things we can touch, yes, it can be cables and it can also be a couple of other things. Now, something else I would like to mention to you guys with regards to the physical layer, just in case you don't know, the physical layer actually specifies some of the following. One of the things it specifies is the physical topology. Please don't confuse that with the logical topology. So it specifies the physical topology, and it also specifies the physical interface. Alright, so I think that is enough for now about layer 1 being your physical layer. Let's go back to our list of layers, or should I say our list of rules. So this is our list of rules, once again, the OSI model. So we discussed layer 1, let's move on to layer 2, which is called the data link layer. Now folks, the data link layer is basically a foundation layer for protocols that will begin to stack on top of layer 2. At the data link layer, a segment is one where all nodes can send traffic to one another using hardware addresses, regardless of whether they share access to the same media. Now, the hardware addresses is sometimes referred to as layer 2 addresses. Just in case you didn't know, we sometimes call these hardware addresses layer 2 addresses. Some folks will just call them the physical address or MAC address. It's got so many names, but you can call it a physical address, you can call it a MAC address, you can call it a layer 2 address. Choose your poison. Anyway, a layer 2 segment, folks, might include multiple physical segments. This is referred to as a logical topology. And that's once again not to be confused with the one I mentioned earlier, which was a physical topology. Now, folks, besides the data link layer being referred to as layer 2 or the switching layer in some cases, so yeah, I kind of let that one slip. It's also referred to as a data link control layer, or should I say DLC layer for short. Now, if you're wondering why is it sometimes called the switching layer, this is because switches actually work at layer 2, and they make their forwarding decisions based on layer 2 addresses, which is your MAC addresses. So the next time you see a network switch, guys, they are usually found in layer 2, or we normally associate them with layer 2, and they make their forwarding decisions based on layer 2 addresses, which are your MAC addresses, or I suppose you can also call them physical addresses. Now, as for why it's sometimes called the DLC layer, because that one is a bit confusing, this is because there will sometimes be a bunch of protocols on this layer which will run as DLC protocols. This includes things like, for example, MAC addresses, which we mentioned earlier, just to give you an idea. Now, just for interest's sake, folks, some of the devices you'll find that actually operate on layer 2 would be devices like your network interface cards, which we call NIC for short. And this could potentially be something like a bridge, a switch, obviously, which we mentioned earlier, and then, of course, wireless access points, which we call AP for short. So you can see there we now mention the wireless access points. So under layer 2, you get the actual wireless access point, which is the actual device. And under layer 1 from earlier, that would just be the wireless transmission between said access points. So be very careful not to confuse those two. Now, going back to our little rules list, or should I say OSI model, let's move on to layer 3, being the network layer. Now, this layer is sometimes referred to as the routing layer or routing layer. Depending on which country you're from, you might pronounce this differently. Some countries pronounce this as routing, some pronounce it as routing. Potato, potato, I think you guys know what I mean. So this layer is sometimes referred to as the routing layer because this layer is associated with IP addresses. So layer 2, the previous one, is associated with MAC addresses. Layer 3 is associated with IP addresses. You can probably already guess that the router works at layer 3. since, well, it's kind of the same name. So just like switches, which you find on layer 2, which makes their forwarding decisions based on layer 2 addresses, like MAC addresses, routers, which we find in layer 3, they make their forwarding decisions based on layer 3 addresses, which we call IP addresses. You'll find these IP addresses are extremely common in just about any network you can find and just about any device you can find, and they make their forwarding decisions based on something like the IP address, which is probably a layer 3 device. All right, and then something else I would like to mention with regards to this little routing layer, switching layer, stuff. So we're currently on the routing layer, which we associate with IP address. I suppose you can call it a routing layer, IP address layer. It's got so many names. So this network layer, guys, is also responsible for moving data around a network of networks. I kid you not. So a router does something called routing, which is why it has that name. So a routing does routing, or a router does routing, however you want to pronounce that. So it routes across multiple networks, and this is known as an internetwork or the internet. Now, while the data link layer is capable of forwarding data by using hardware addresses within a single segment, the network layer moves information around an internetwork by using logical network and host IDs. The network layer forwards information between networks by examining the destination network layer address or logical network address. The packet is then forwarded router by router, or should I say hop by hop, as some people might call it, through the internetwork or internet to the target network. So a lot of people just call these hops, but they're actually routers. So every time you go from one router to another router, it's actually considered a hop. If any of you guys have ever gone into command prompt and you did a trace it, you'll see it says it traces up to a maximum of 30 hops. So in other words, it traces up to a maximum of 30 routers in most cases. Now, once it has reached its destination network, guys, the hardware address, once again being the MAC address, can be used to deliver the packet to the target node. Now, moving back to the rules list here, or should I say the OSI model, the first three layers, guys, that we have discussed now of the OSI model are primarily concerned with moving frames and datagrams between nodes and networks. At the transport layer, however, which is also known as the end-to-end or host-to-host layer, the contents of the packets becomes significant now. Any given host on a network will be communicating with many other hosts using many different types of networking data. One of the functions of the transport layer is to identify each type of network application by assigning it a port number. For example, data requested from an HTTP web application can be identified as port 80. Now, this transport layer can also be called the post office layer, guys. I kid you not, since this is the layer that describes how data is delivered and where it's being delivered. The protocols we use in this layer is protocols such as TCP, which stands for Transmission Control Protocol, and also UDP, which stands for User Datagram Protocol. Now, how this all works is, think of a web page, guys, that you need to load, where the web page is so freaking large that you can't load it all in just one frame. What's going to happen in that situation now is it will actually be split up into separate frames. And then at the destination, being your computer of course, it will be reconstructed or reassembled back together, giving you the full page and of course the end result. Pretty cool, right? Now the interesting thing here is computers don't actually receive these frames in the correct order, believe it or not. But yet, you get the correct end result. But we are talking about computers here, you've got to remember that. So computers do not need to receive this stuff in the correct order. It will reconstruct it and then you can see this in a logical order as a human being. As long as the computer receives all the frames of packets, it will be able to get to the end result. Sadly, as human beings, well, we need to receive things for the most part in a logical order, otherwise our heads are gonna, well, not be able to comprehend the end result. Alright folks, so let's move further up that OSI model, or should I say that little ladder. This layer, guys, is going to be called the session layer. So we're moving into layer 5. That would be the session layer. This layer's job is the communication management between devices. It will do things like start, stop, or restart the communication session between one device and another. Most application protocols require the exchange of multiple messages between the client and server. This exchange of such a sequence of messages is actually called a session, or some people call it a dialogue. The session layer represents functions that administer the process of establishing a dialogue, managing data transfer, and then ending, or should I say tearing down, the session. So in short, folks, the session layer actually allows users on different machines to establish active communication sessions between them. It is responsible for things like establishing, maintaining, synchronizing, and of course terminating sessions between end user applications. This layer basically establishes a connection between the session entities, if you want to call it that. Now, looking at the workings of the session layer, it uses the services provided by the transport layer, enables applications to establish and maintain sessions, and to synchronize the sessions. Alright folks, and then moving up to our sixth layer of the OSI model. Slowly but surely we're getting to the end. We're almost there. So this layer 6, this is known as the presentation layer, guys. This layer is also known as the translator layer. I kid you not, translator layer, since it basically acts like a translator or a converter of sorts. So what this layer does is actually pretty simple. When your machine receives data, guys, it's not going to be in a format that you, as a human being, can understand, which is pretty much what I was referring to earlier when I said your PC also won't receive frames in a logical order. What the presentation layer will do is it's going to take the data and coding for what you receive and then just convert it and display it in a format that we as human beings can actually understand and comprehend. I suppose, in a manner of speaking, it's kind of like a converter or a translator if you think about it. Now guys, the presentation layer can also be conceived as supporting data compression and encryption. So any form of character encryption or application will happen at layer 6. You'll find that the presentation layer is often combined with the application layer because the functionality is so closely associated with our ability to use these applications. The main responsibility of the presentation layer is to provide or define the data format and encryption. Alright, so moving back to the OSI model list, or our little rules list, guys, for the last time. So the last layer here, guys, is layer 7, which is known as the application layer. So this layer is effectively the layer that we as human beings are able to see, or at the very least that gets presented to us. So if you were to go to your browser and open a web page of your choice, what you would see there is basically the application layer doing its thing. Everything you see there on the screen is actually layer 7, which is the application layer. Now, some of the application layer protocols could be stuff like if you want to find yourself using a browser with HTTP or HTTPS, or if you're transferring a file with FTP. You might also find yourself resolving a name with DNS or using email with POP3. All of these are actually, believe it or not, the application layer protocols, guys. Well, folks, that is pretty much the OSI model summarized into a bite-sized video, if you can still call it that. I mean, this is literally just one topic, kind of, sort of, and the video is still fairly big. But it's a difficult topic. It's a very difficult topic for a lot of people to grasp. It's a very difficult topic to explain, believe it or not. So I hope you guys have given this video a like. If you haven't given the video a like yet, please do me a favor. Give the video a like. It's a very difficult topic to explain. And if you found value out of this video, and if you'd like to know when lesson 3 comes out in this playlist, or when I release other videos, maybe also consider subscribing, and then at least you won't miss that. Now guys, before we call it quits on this specific video, just a quick shout out to all the sponsors and Patreons and all that of this channel. And this includes those of you clicking on the thanks button below the video, and those of you guys just buying me a milkshake and all that. Just by the way, if you guys want to support the channel, you will find all that information in the video description down below. So guys, here, thank you very much to all the Patreon sponsors. Thank you very much, guys. I appreciate each and every one of you guys. So there's a list of the Patreons. Here's a list of the guys that's making donations via PayPal. Thank you very much, guys. Appreciate all of you guys. Thank you very much. And like I said earlier, thank you to those of you guys that's just been buying me Milkshake or, whatever, just clicking on the thanks button below the video if there is one. I know some countries doesn't display it. Thanks to you guys as well. And then the very last thing I'll mention is I do have a Discord server, guys. So if you know what Discord server is, if you have it and if you'd like to join my server, that will be the very last link in the video description. It's way at the bottom of the video description. Feel free to join that. It's an IT community of like-minded people. I'm in there. Other IT trainers are in there. Other people studying the NewTek Plus course are in there. Just to mention a few. So if you'd like to ask questions, you can ask them there. If you'd like to answer other people's questions, you can do that there. It's all in there. All right, folks, I hope you've learned something in this video. And if you have, I will see you in lesson 3 of the CompTIA Network Plus course.